Hey guys, this is Mrs. Amspacher again. I'm here to go over question 5 with you, which is determining whether or not the tables below are linear or nonlinear. In this case, specifically, we're looking at inverse. And then if it is linear, we're writing a linear equation for it. If it's an inverse relationship, we're going to write an inverse equation for the table. So the first thing I'm going to do in table A is I'm going to check to see if we have a slope. So I'm going to look at how my x values change. First I went from 1 to 7, which shows that I increased by 6. Then I went from 7 to 14, which is an increase of 7. Then if I check my change in y, I decreased by 60 when I went from 70 to 10. And then decreased by 5 when I went from 10 to 5. Now, if I try to check the slope, I have for the first one a slope of negative 60 over 6, which is same thing as negative 10. For my second one, I have a slope of negative 5 over 7, which does not simplify down to any other smaller fraction. And as we can see, negative 10 and negative 5 over 7 do not match. So I know that it is not linear, meaning it has to be inverse. So if I check now, in order to write my equation for inverse, I have to have a k value. So I'm going to check here in my table by multiplying my x's. 1 times 70 is 70. 7 times 10, 70. And 14 times 5 is also 70. So I know my k value is 70. So one of the equations I can write is simply just x times y equals 70. Or I could write it as y equals 70 over x. Or I could write x equals 70 over y. Any one of those equations would represent the inverse relationship in table A. If I look at table B, do the same process. First I increase by 1, going from 2 to 3. Then I increase by 1 again, going from 3 to 4. Next I'm going to check my y values. Here when I went from 24 down to 16 down to 12, you can tell that we're decreasing by a different amount every time. Here I'm decreasing by 8. And then I decreased by 4. So if I go to check my slope, my first slope would be negative 8 over 1, which is the same thing as negative 8. My other slope is negative 4 over 1, which is negative 4. As you can see, my slopes here do not match, so that means it can't be linear, has to be inverse. So if I check my k value by multiplying my x and my y, 2 times 24 is 48. 3 times 16, 48, and 4 times 12, 48. So I know my k value is 48, so once again we have one of 3 options for the equation. X times y equals 48, or y equals 48 over x, or x equals 48 over y. Again, you do not need all 3 equations, you just need one of them. If we look at the next section, part C and D, again, I'm going to go through the same process. So here my x values are increasing by 1. My y values, be careful when you calculate this, are increasing by 11. So one way I know it's not inverse is because my constant rate of change would be 11 over 1, which is the same thing as 11. I also know that it is not going to be inverse because as my x's increase, the y's increase. In order to have an inverse relationship, as one goes up, the other needs to go down. So now my equation comes down to, well, since I have slope, I need to find my y-intercept. So I could extend the table back to look for when x is 0. In this case, I'm just going to pick an ordered pair like 55, and use my slope of 11 and substitute it into y equals mx plus b. Okay, I'm going to equation solve for it just like we did on the investigation 2 quiz. So my y value is 55, my slope's 11, and my x value is 5. And then if I just simplify this, I'm going to get 55 equals 11 times 5 is 55, plus b. Solving for b, taking away 55 from both sides, I'm going to get 0 equals b. So my y-intercept is 0, my slope is 11, so putting this together, y equals 11x plus 0, or again, you could just have y equals 11x. If I look at part D, same process. Here my slope, if I check for it, my x's increase by 2, and then I increase by 4. My y values increase by 9, and then they increase by 18. So if I check my slope off to the side here, my slope would be 9 over 2 for the first one, or the second one, 18 over 4, which is the same thing as 9 over 2. So I do get the same slope, so it has to be linear, cannot be inverse. And then if I check for my y-intercept, in this case, I'm going to use my pattern in my table. So if I go back 2 more here, that's going to put me at 0 for x. If I continue the pattern backwards here, if I go back 9 for y, that's going to put me at 0, making my y-intercept the ordered pair 0, 0. So if I write my equation, it should be y equals 9 over 2x plus 0. Or again, you could have just y equals 9 over 2x. I hope you found this helpful and that you have a better understanding for determining if a table is linear or nonlinear, and then writing the equation if it is inverse or linear. Thank you.